Scheduling discipline chooses the datagram to be sent out on the outgoing link. This could be done using a simple first-in, first-out scheduling. This, in the real world, is similar to a person waiting in a line for a cashier in a single payment line. In that line, the first person arriving at the line will pay first and leave first. In the FIFO scheduling, in the output port queue, the packets arriving to the output port queue will be put on the output line in the same order on arrival, similar to the payment line queue. If a packet arrives to a full queue, there are different ways to decide which packet to drop. It could be drop tail, means newly arriving packet to a full queue will be dropped. Similar to what you may see in a payment line if it is too busy and the cashier will close after servicing a number of people already in line and therefore will not provide the service to you. There are also other ways of deciding the packet discard. This could be implemented on random drop of packets or based on their priority. Scheduling of the packets could also be performed based on priority. In this method, multiple priorities are defined for packets, and the priority class of a packet may depend on the marking of the packet with that priority or parts of its header information. Using priority scheduling, the packets are queued on different queues based on their priority upon arrival. For example, in the figure, the top queue with the dark blue packets shows the high priority queue, and the lower queue with the light blue packets shows the low priority queue. The link server will serve the higher priority packets first and the lower priority queue after when there is no higher priority packet available. Can you think of a real-world example? Maybe airplane boarding with different ticket classes? The figure on the right shows packets 1, 3, and 4 of high priority and packets 2 and 5 of low priority. If it takes 3 units of time to send out each packet, given the arrivals and priorities, 1 and 3 will be scheduled first. Then, because there is no priority packet, packet 2, which is a low priority packet, could be scheduled. Then packet 4, which has arrived after transmission of packet 2 has started. Followed by packet 5, because again, at that time, there is no priority packet waiting for their line. A problem that might happen with priority queuing is that if the arrival of packets in the high priority queue is high enough, the packets on the low priority queue will not get the chance of receiving the access to the output link. This could be addressed with round robin, which scans class queues going in rounds. And if there are packets available in each of the queues, it will send one complete packet from each class on each round. Round robin queuing applied to packets 1, 2, and 4 with high priority, and packets 3 and 5 with low priority arriving at times will result in sending the packets 1, 3, 2, 4, and 5 respectively. Note that packet 3 arrived after packet 2 and had lower priority, but was scheduled before it, as it was the turn for that queue. Can you name a real-world example of a round-robin scheduling? Have you seen traffic lights merging a few lines of traffic into one? They usually use round-robin. Round-robin provides the same opportunity to packets in different queues, but sometimes we need higher weight of our outgoing link used for a specific set of priority packets. That could be achieved through weighted fair queuing. Weighted fair queuing is a generalized round robin that could assign a weighted amount of service to the packets in each cycle. It will go around among the queues similar to round robin, but it allows a number of packets from that queue proportional to the weight of that queue. So, for example, if W1, the weight of Q1 in the figure is 1, W2 is 4, and W3 is 2, in each round, it will schedule 1 packet from Q1, 4 from Q2, and 2 from Q3. However, as depicted in the figure, Q2 might have only 2 packets when a round scheduling happens. In this case, any available packets up to the wait limit will be served before going to the next queue in the round, making the serving of 1, 2, and 2 in round 1 for Q1, Q2, and Q3 in the figure.